Let's create a DFA for the language W, where W has length at least 3 and its third symbol is a 0. Now, what are we looking for here precisely? Well, we're looking for, say we have an input string consisting of zeros and ones as defined by our alphabet here. 0, 1 means we're going to have zeros and ones in our input string. So if we have a bunch of random zeros and ones, say this string here, we're first looking for if we have a length of at least 3, so length at least 3, and then we're checking if the third symbol is a 0. Now, is the length at least 3? Well, yeah, just by looking at it, we can see that we have a much longer string than 3. And then is the third symbol a 0? Well, 1, 2, 3. The third symbol is a 0. So therefore, this is going to accept because both of these criteria are met. However, if we were to change this symbol here to a 1, well, now the third symbol is a 0, is a 1. So now we would reject this. Even though our string is of length at least 3, we still have to reject this entire language here. So this would be a rejecting string. So that's kind of what we're looking for here. And let's create our DFA. So as we always do, we're going to have an initial state. We'll call this state 1. And then let's create a transition. We'll say it's a transition on 0 to state 2. This means that if we have an input string 0, let's say, we're going to feed our string into our DFA. We're going to start at state 1, and then we're going to read the first character. The first character is a 0, so we're going to follow the 0 arrow, which is right here, to state 2. Now, we can't just have a transition on 0 and ignore 1, because we're looking for length here. Length is not just, the amount of zeros or the amount of ones, it's the amount of any character. If we have, a string that's 0, 0, 0, or 1, 1, 1, or 0, 1, 1, or 1, 1, 0, it doesn't matter. The length of these are all 3. So it's not conditional on any zeros or ones. We're essentially just looking for any character. So we can transition on 0 and 1 to state 2. So if we have an input string 1, we're going to go from state 1 to state 2. And if we have an input string 0, we're going to go from state 1 to state 2 as well. It doesn't matter if it's a 0 or a 1. Now, what happens if we create another transition, kind of identical to the previous one, from state 2 to state 3? Well, now if we have an input string, let's say it's like 0, 1, for example, we go from state 1 to state 2 upon reading the first character. Then on state 2 to state 3, we read the first character, we go from state 2 to state 3. What's happening here is the length at state 1 is going to be 0. The length at state 2 is going to be 1. The length at state 3 is going to be 2. If you'll notice, we need, to consume a character for every transition, essentially. So to go from state 1 to state 2, we need one character. And then to go from state 2 to state 3, we need another character. So the length is increasing linearly based on the transition. Every transition means one length or one character consumed. So if we create another transition on 0, 1 to a new state, we'll call this state 4. Well, the length naturally is going to be 3 on state 4 because we need 3 characters to jump all the way to state 4. Now we're looking for a length of at least 3, so the length could be 3 like we've solved here. If we're on state 4, that means we have length of 3. But it could be 3, or it could be 4, 5, 6, 17, 7 million. It doesn't matter what the length is as long as it's greater than 3. So if we're on state 4, we can just loop on ourselves on 0 and 1. So we just stay in place. We can create a transition on 0, 1 to go to a new state, state 5, and then keep doing that forever until state 7 million. But it's just a lot more efficient to just stay in place and say that 4 is going to be where we're accepting. If we have a length of at least 3, we're on state 4. So this is going to be like length 3 plus. But that's not the full diagram. We also need to account for the third symbol in the string being a 0. So how this is going to work is essentially if we have an input string like 0, 1, 0, we're going to, upon reading this third character here, we want to check what it is. We want to check if it's a 0 or a 1. throughout this whole diagram, we've been kind of just moving based on whatever character it is. If it's a 0 or a 1, we don't care, just go to the next state. However, if it's a 1 in this case on the third character, we want to go somewhere else. Essentially, we want to be like, if it's on a 0, we want to go to, an accept state. But if it's on a 1, then we want to go to a reject state. Because if the third symbol is a 1, then we can't accept this string no matter what. There's nothing we can do. So to do that, let's see where our third character is being read. So our first character is being read on state 1, and then our second character is being read on state 2, then our third character is being read on state 3. So we're going to erase this 1 transition, and then we're going to separate it. So we're going to have a 1 transition going to a new state. We'll call this state 5. State 5 is going to be our reject state, because if we go on state 3 to state 5, that means we have a 1 in the third position. So we're going to reject this automatically. And it doesn't matter if we have, say we have the string 1, 1, 1, and then a bunch of zeros after. It doesn't matter what's after. It literally does not matter because our third symbol is a 1, so we can never accept. So we can just stay in place on everything, 0, 1, and it's kind of just like a dead end here where we can't escape this. We already know we're going to reject. Perfect. So what's happening here is we have our input string. We feed it into our DFA. We go from state 1 to state 2, and then state 2 to state 3. Then on state 3, we check, is it a 0 or a 1? If it's a 0, then we go to state 4, and we accept. Everything's good. But if it's a 1, then we reject. Everything's gone wrong. And the neat thing about this is if we're on state 4, that means we have a length of 3, as we noted before, and our third character is 0. So w at 3 is equal to 0. So it meets both of our criteria by just simply being on state 4. If we were to change this by saying we have a length of at least 4, well, then we'd need to create a new state and go to state 5 and then make sure that our length is at least 4. But here our length is 3 and our third character should be 0. This diagram matches that. Feel free to test it for any input strings you'd like. You can write some input strings up above and just go through the diagram, feed the numbers in one by one. And that's best practice for testing your DFAs. But something I always like to check for before I finish a DFA is every single state in a DFA needs the entire alphabet as a transition coming out of it, which means every state needs a 0 arrow and a 1 arrow coming out of it, because our alphabet is 0, 1. So state 1 has a 0 arrow and a 1 arrow coming out of it. State 2 also has a 0 and a 1. State 3, 0, 1. State 4, 0, 1. And state 5, 0, 1. That's perfect. So this looks like our final DFA. I hope this made sense, and feel free to ask any questions in the comments below. I try to answer everything, so thank you for watching.